Good afternoon, children.
Good afternoon.
So today, this period, we are going to start with the new chapter, chapter 3, trigonometric functions. Okay, we are going to start with the new chapter, trigonometric functions. Okay, already you are familiar with this chapter, isn't trigonometry? What is trigonometry? It is the branch of mathematics, isn't it? Which gives a relation between the sides and angles of a triangle. It gives a relation. It relates the sides and angles of a triangle. Okay. Here, in 10th standard, we have learned only the basic terms. Here we are going to learn little more detail. We are going to learn some formulas. Okay, here we are learning only the theoretical part. We are going to learn few formulas. We use these formulas next year throughout in that year, that is in differentiation, integration, everything. We use all these formulas. So what are the formulas we learn here are very important. Okay. You can start with this one. Write the heading, trigonometric functions. Trigonometric functions. Okay. So keep your textbooks also side with you. I hope you are all having your textbook. Take the textbook and keep it ready. After explaining all these terms, I'll ask you to mark some important points in your textbook. Mark all these points. Okay. Now for the time being, no need to open. Okay. So listen. First, we are going to start with angles. What does mean angle? Angle means when two rays originate from the same point, we will get an angle. Yes or no? When two rays start from a common point, two rays starting from a common point forms an angle. Okay, so we'll be getting an angle. So here, same way, instead of giving this, suppose you are given an initial ray. Suppose you are given with an initial side. Okay, so this ray, this line, we are going to rotate it. We are rotating it. We can rotate in this way as well as we can rotate like this. Isn't it? This way, if we rotate means we call it as anti-clockwise. Anti-clockwise. And this way we call it as clockwise. So now the clock will be moving. The needle will be moving like this. So this way we call it as clockwise. So what is angle? Here, now we are going to learn angle as it is the measure of rotation of a ray. Suppose OA is a ray. It is the measure of rotation of a ray about its initial point. So this is the initial point. This is a ray. Suppose this ray is moving. So it can move in both the ways. It can move anti-clockwise or it can move in clockwise. So if this is the initial ray, this one fixed point is there, that one we call it as vertex. And this one we call this as initial side. So it is the rotation of the ray with respect to the fixed point, with respect to the initial point. Suppose the ray is moving anti-clockwise means this is the angle formed. This is the terminal side. This is the ending side. So we call this as terminal side. So we measure anti-clockwise. So this is the angle formed. So in this case, whenever we measure it anti-clockwise, we call the angle to be as positive angle. Okay, whenever we measure it anti-clockwise, it will be positive angle. Suppose this is the initial side. Suppose this is the initial side. This is the vertex. Okay, and this initial side, suppose OA is the ray. If it moves clockwise, and suppose this is the terminal one. Suppose it ends here. B is the final point. Now here we move it. We are moving the ray clockwise. We are moving the ray clockwise. In that case, we call the angle to be negative angle. Call the angle to be negative angle. Okay. So whenever the ray is moving anti-clockwise, the angle will get positive. And when it moves clockwise, we'll be getting the angle as. Okay. So positive and negative angle, is it okay? Now imagine this ray. Suppose this is the ray. It moves. It moves like this and again comes back to its original position. So that means it takes full complete rotation. In that case, what is the angle covered? What is the angle covered? In one full rotation, what is the angle made here? 360. Okay. Initial line is there. Suppose this is the initial line. This is the initial line OA. Now what happens? This ray is moving. Again, it's moving. It comes like this. When it comes like this, it will become a straight line. Then it's moving, and finally it coincides. So in that case, what is the angle covered by this ring? It is 360 degree full angle. Okay. And whenever we measure it, usually we measure the angle in degrees. 360 degrees. Usually we measure the angle in degrees, 360 degrees. If it is straight angle, we call this as 180 degrees. Right angle means 90 degree. Okay, if this angle, okay, suppose this is a ray, and if it is like this means when we measure it, it will become 270 degree. It will become 270 degree. Or if you take it reverse, that is in the anti-clockwise means it will be same as, if you take it clockwise, it will be minus 90. Will it be minus 90? This is, okay, this is the starting ray. So here it will be 0. If you are measuring like this, it will be 90. Here you will get 90 plus 90 plus 90. 90 plus 90, 180. 180 plus 90, 270. If I measure this clockwise, it will be same as minus 90. Similarly, suppose a ray is given mark. Suppose this is the initial point. And this is the terminal one. So here, when we mark it, we mark the angle as negative 30. We mark the angle using negative numbers. So degree measure is the usual measure till now what we have learned, degree. The measure of an angle is always we use it as degree. Okay. In physics, you might have learned about the degrees, minutes. Okay. So write the heading degree measure. Write the side heading degree measure. If the rotation from the initial side to the terminal side, if the rotation from the initial side to the terminal side if the rotation from the initial side to the terminal side is 360 degree from the initial side to the terminal side. That means when it completes one full rotation. Okay, when it completes one full rotation. Okay, so that is, listen, when it takes one full complete round, okay, when it completes, suppose this is like this, suppose this O is a ray. When it starts from here and when it comes back to this position, it makes 360 degrees. Okay, so if the rotation from the initial side to the terminal side is 360 degrees, then 1 by 360th of the revolution, 1 by 360th of the revolution is called 1 degree. 1 by 360th of the revolution is called 1 degree. 1 by 360th of a revolution is called 1 degree. Okay, in one revolution, it completes 360 degree. So what is 1 degree? It is the angle covered in 1 by 360th of the revolution. In one revolution, it covers 360 degrees. Is it clear, children? In one revolution, it covers 360 degree. Therefore, 1 degree means it is the angle measured in 1 by 360th of the revolution. 1 by 360th of the revolution is called 1 degree. 1 by 3/60th of the revolution is called 1 degree. Okay, now listen. Now listen, children. So here we are going to learn few more points here. 1 degree. 1 degree, we can split this into 60 minutes. Minutes means we write only simple dash, 1 dash. Okay, smaller units of degree, we call it as minutes. After writing 60, we will write 1 hyphen like simple. That one we call it as 60 minutes. Similarly, 1 minute. 1 minute can be divided into 60 seconds. 60 seconds means we write 2 dash. 1 degree is 60 minutes and 1 minute is 60 seconds. In one revolution, it covers 360 degrees. One revolution, one full revolution means, one complete revolution means 360 degrees. Therefore, in 1 degree means it is 60 minutes. And 1 minute is 60 seconds. So this is the measure, degree measure. Whenever we are using protractor and all, we used to mark the angles as degree, isn't it? 45 degree, 90 degree and all. Okay. This year, we are going to learn another measure called radian measure. We are going to use another measure called radian measure. So first, this degree measure, is it clear? The usual measure. When we measure an angle, we usually give it in degrees, 30 degree, 45 degree and all we used to say. Okay. The smaller units of degree is 1 degree means we can further split into 60 minutes. And 1 minute we can further split it into 60 seconds. Is it okay up to this? The next one we are going to learn is radian measure. Write the heading. Next one is radian measure. Radian measure. Okay. So for this, listen all of you. Consider a unit circle. Consider a unit circle. What is meant by unit circle? Unit circle means radius will be 1 unit. Unit circle means a circle whose radius is 1 unit. So consider a unit circle. Okay. Now listen, what is this part called? This part we call it as, what is this part? Arc. This is called arc. Okay. So consider an arc length of 1 unit. You draw a circle of unit radius and consider an arc length of 1 unit. Okay, this arc length will subtend one angle here. This is called 1 radian. Is it clear? Consider a unit circle. Now it's in the unit circle, you consider an arc of length 1 unit. This unit arc will subtend an angle at the center and that is called 1 radian. Okay, that is called 1 radian. Here also we can mark it as positive and negative. Listen children, suppose this is a unit circle. Suppose O is the center. Suppose we can take this as unit line. When we measure in this direction, we call this as positive 1 radian. When we measure here, we call this as negative 1 radian. Okay, if this is 1 unit, and here also it is 1 unit. Okay, positive, okay, and negative. Is it clear? Is it okay? So consider a unit circle of radius 1 unit, and arc length of 1 unit will subtend some angle. That angle only we call it as 1 radian. So 1 unit will be substituting 1 radian. Okay, listen all of you. 1 unit will be substituting 1 radian. So now look at the circle. This is the circumference of the circle, isn't it? What is the circumference of the circle? It is 2 pi r. It is 2 pi r. R is 1 because we are taking r is 1. We are taking a unit circle. So in 1 full revolution, it makes 2 pi radians. Is it clear? Okay. If the arc length is 1 unit, it subtends 1 radian. Are you able to understand? Arc length of 1 unit subtends 1 radian. So if you take arc length of 2 units, it will subtend 2 radian. Same way, if you consider the full arc length means you are considering the full circle, means it is the circumference of the circle 2 pi r. The radius is 1, so circumference will be 2 pi. So arc length of 2 pi will form 2 pi radians, will form an angle of 2 pi radians. That means 2 pi radians will be same as earlier we learned. One full revolution means it is 360 degrees. So this is the relation between the degrees and radians. 2 pi radians will be same as 360 degrees. 2 pi radian will be same as 360 radian. Is it clear? Up to this, is it okay, children? No. So for this part, is it clear? Are you covered? Unit circle, is it clear? What is meant by 1 radian? If you consider an arc length of 1 unit in a unit circle, okay? If you consider an arc length of 1 unit in a unit circle, it will subtend some angle at that center. That center, that angle, we call it as 1 radian. Angle subtended by a unit arc at the center in a unit circle is called 1 radian. So if the arc length is 1 unit, it subtends 1 radian. If I take arc length 2 units, then it will subtend 2 radian. Okay, like that. If you consider the full circle, what is the circumference of the circle? 2 pi r. So arc length arc of length 2 pi r, r is 1. So arc length 2 pi will be subtending 2 pi radians. Arc length of 1 unit will subtend 1 radian. 2 pi will be arc length of 2 unit will subtend 2 radian. So arc length of 2 pi will subtend 2 pi radian. 2 pi radian means one full complete circle. But what we know, what is meant by complete circle? Full circle means it is 360 degrees. So we get 2 pi radian will be same as 360 degrees. 2 pi radian will be same as 360 degrees. Okay. So 2 pi means 360. So hereafter, whenever we measure the angle, we'll be using it in terms of radians. Okay. We'll be using in terms of radians. Okay. So write down the next point. 2 pi radians will be same as 360 degrees. Therefore, what will be pi radian? What will be pi radian? Pi means 2 pi means 360. Pi will be 180 degrees. So now find out how will you represent 90? How will you represent 45? What about 30, 60, 270? Find out in terms of radians. So this is in degrees. 2 pi means we get 360. 180 means it is pi. So what about 90, 45, 30, 60 and 270? So what about 90 degree? How will you write 90 degree? Pi by 2 radians. pi by 2 radians. Or if we simply write pi by 2, we can understand that it is given in radians. What about 45?
Pi by 4.
Pi by 4. Instead of saying 45, hereafter we say pi by 4. Pi by 4 radians. 30 means pi by 6. 60.
Pi by 3.
Pi by 3. And what about 270? 270. 270 means we can write this as 9 into or 90 into 3. Isn't it? So 90 into 3. It will be same as?
3 pi by.
Yes, it is 3 pi by 2. 270 radians means it is 270 degrees means it is 3 pi by 2 radians. It will be 3 pi by 2 radians. Okay. So next heading. Next heading. Relation between degree and radian. Next heading. Relation between degree and radian. Relation between degree and radian. So 2 pi radians will be same as 2 pi radians will be same as 360 degrees. Therefore, 1 radian will be same as, what will be 1 radian? 360 by 2 pi, which is same as 180 by pi. 2 pi radians is 360 degree. Therefore, what is 1 radian? You divide by 2 pi. 360 by 2 pi, which is 180 by pi degrees. So this is a relation. 1 radian is 180 by pi degrees. So to convert, listen children, this is this form. Okay, this one you have to learn it. So to convert degree to radians. Okay, to convert degrees to radians, what you have to do? Multiply by pi by 180. If you are given degree and to convert that into radians, what you can do? Multiply by pi by 180. Similarly, to convert radians to degree, we have to multiply by, okay, look at here, 1 radian is multiply by 180 by pi. To convert radians to degrees, we have to multiply by 180 by pi. Okay, so to convert degrees to radians, you multiply by pi by 180. To convert radians to degree, multiply by 180 by pi. Okay. So how to convert and all, when we do the problems, it will be more clear. So now take your textbook. Just go through the text, read your textbook, page number 49. Start reading what we discussed. It is given there. You read it. Mark all the important points. That is up to page number 52. Start reading from 49, 50, 51, 52. Mark it. Read all the things. Okay, read up to page number 52. Okay, I'll mark your attendance that time. Do it. One more formula. After discussing one more formula, we can end the session now. Okay. Now listen, children. The next one is, write down the heading, arc length. Last year we have learned length of an arc. What is the formula we have learned? What is the formula? We have learned length of the arc is given by theta by 360 into, is it 2 pi r? Is that no? Here we write theta in degrees. Is that no? 60 degree, 45 degree. We substituted this value and calculated. Here, now look at here. 6 theta into, now 2 if you cancel it, it will be same as pi by 180 into r. Is it correct? We are multiplying an angle by pi by 180. That means, what does it mean? Last year we did this one, but we don't know why we are doing it. Now, look at here. Now you can understand this concept. Theta degree, we multiply by pi by 180. That means we convert that into radians. Okay, that means here we are converting it into radians. So L is equal to, hereafter we will be using the formula L is equal to r theta, or theta is the angle in radians. Earlier, last year and all, we used the formula length of the arc is theta by 360 into 2 pi r. But 2, if you cancel it 360, we will get pi by 180. So look at here, an angle, we are multiplying by pi by 180. Earlier only we wrote, to convert an angle in degrees to radians, we should multiply it by pi by 180. So here we are multiplying the angle. We are multiplying the angle by pi by 180. That means we are converting it into radians. Okay. Hereafter, whenever we use theta, angle in calculation process means, you should know that one. We will be allowed to use degree, okay, in radians, not in degrees. Whenever we use theta in calculation, okay, in physics and all, you will be using this theta. Okay. As or no? In calculations, are you using that part? No. So whenever we are using theta in calculation part and all means, it will be in terms of radians. Okay. Okay, we can't use degree as such in calculation. Okay. So length of the arc, hereafter, we will be learning the formula L is equal to r theta. What is theta? It is the angle at this, okay, angle subtended by the arc at the center in radians. So L is equal to r theta is the formula. Okay, when you go for higher studies and all also, we will be learning this formula itself. L is equal to r theta. Length of the arc is given by L is equal to r theta. Write down this one. L is r theta, where theta is the angle in radians. Okay, this conversion and problems and all, we can start with this in the next class. Okay, I'll leave you because as you're having exam tomorrow, sit and start preparing for the exam. Tomorrow, which exam you're going to write? Okay, thank you.
Thank you.
Bye.